Hi guys, this is Mr. Ropes and welcome back to Statistics. In this video, we're going to look at transformation. So what happens if we transform our distribution somehow? What happens to the mean? What happens to the standard deviation? And we're going to look at converting a distribution after we look at what happens with those. And then we're going to look at combining distributions. All right, so first up, we're going to play with our calculators. All right, so what we are going to need to do is we're going to need to put this list of numbers into our calculator and calculate the mean, median, and standard deviation. So I have gone ahead and already put that list in. So remember, we go to Stat, Edit, and then we would just type in those numbers, 10, 13, 14, 15, 15, 18, 20, 22, 26, and 30. All right, you got them all right. And if we want to do the calculations, we do Stat, Calc, one variable stats. I put them in L1. We don't have any frequencies. We'll just press calculate. And there's our mean, 18.3. We can go with our sample standard deviation, which is 6.236. And our median is 16.5. So let me write these down. So we got 18.3, 6.2. So our mean is 18.3. Our standard deviation, which we'll go ahead and call S, is 6.2 and some change. And our median was 16.5, if I remember correctly. All right, so number 2 now down here. Create a second list by adding 5 to each number. Then calculate the mean, the median, and sample standard deviation. How do they compare to the first one? All right. So let's go back to Stat, Edit. So this is real quick and easy. We're going to go to L2. We don't have to type in all the numbers again. We're going to type in at the title, we're going to type in L1, and then we're going to put plus 5, because we want to add 5 to everybody in L1. And we're just going to press enter, and voila, there's our new list. If you look, every number has been increased by 5. So we'll quit that, and we'll go back into Stat, go over to Calc, one variable stats. Now we are working with L2, so second 2 to get to L2. Enter a couple times, and voila. Let's see, our mean is 23.3. Our standard deviation is 6.2. Oh, it was 6.2 before. And our median is 21.5. Let's see if I can remember those. So we've got 21.5, 6.2, and 23.3. So for this one, we've got X bar is 23.3. Standard deviation is 6.23. Still, again, I'll put the 3 there this time. And median was 21.5. So how did it change? How did each of these change? So it looks like the 18.3 to 23.3, that went up by 5. This one stayed the same. Standard deviation didn't change. The median also went up by 5. So it looks like if we add 5 to everything in our list, so we took what data values were in our list and added 5, then that was the same thing, and we got like a new y value, then that was the same thing that happened to our mean, and that's the same thing that happened to our median, but nothing happened to our standard deviations. All right, what happens now? Let's see, that's yellow, let's use blue. So create a third list by multiplying each of the original numbers by 2 and then checking what happens. All right, so we're going to go back into Stat, Edit. We're going to go to L3, and we're going to do 5 times second L1. Just on the list name, press enter, and there's our new list. Every number is 5 times bigger. So see, oh, we wanted to do 2 times bigger, didn't we? Yep, 2 times, sorry. Easy fix. Go back up to the list name, 2 times second L1. Voila, there we go, 2 times bigger. I can maths. So let's see, Stat, Calc, one variable stats. Now the list we're interested in is L3. And what do we get there? 36.6, 12.47, and 33. So our mean for this guy, 36.6. Our standard deviation was 12.47. And our median was equal to, was it 33? I think it was. All right, so if we multiplied everything by 2, now what happened? So what happened to the 18.3 to get to 36.6? If you said we just multiplied by 2 times 2, you'd be correct. Standard deviation, it was 6.23, and now it's 12. Well, 12 is twice 6. 23 times 2 would be 46, so there's probably another bigger number after the 3, making that to round up. So this was also times 2, and our median went from 16.5 to 33. Well, 16.5 times 2 is also 33. So everything changed here. So when we had our new variable was 2 times our old variable, everything changed by that same amount. So we did times 2. To the mean, the standard deviation, and the median. For here, we just did plus 5 to the mean and to the median, and the standard deviation was the same. So we didn't do anything to the standard deviation. All right, now we've got one more here to try. The green one here. Find a fourth list by multiplying the original list by 2 and adding 5. Calculate the mean, the median, and sample standard deviation. How do they compare? So what do you think is going to happen if we multiply by 2 and add 5 in a new list? So let's go over and edit and make L4. All right, so we're going to take L1. We're going to multiply it by 2 first, because that's what it said to do. And then we're going to add 5. Press enter. There's our new numbers. And let's see, we're going to go back to our home screen. Stat. Calculate one variable stats. It's now in L4. And we get 41.6, 12.47, exactly the same as that. And 38. So 41.6, 38, and exactly the same as we were before. So for this one, our mean equals, what's it, 41.6, was that what it was? Our standard deviation was 12.47, and our median was 38. So let's see, that's this one plus 5. That's 5 more. Here, standard deviation stayed the same. And the median of 33 here, when we added 5 to it, it was just this one plus 5. All right, so we did the times 2 and the plus 5. So the times 2 only affected the standard deviation. The adding didn't affect it. All right, but here the adding and the multiplying affected the mean. So the times 2 and plus 5 affect the mean and the median. The times 2 affects the standard deviation, but not the plus 5. All right, so we have our new variable here was 2 times our old variable plus 5. And so we just basically plug in your old mean, and that gets you your new mean. Plug in your old median, that gets your new median. Plug in your old standard deviation, but forget about the adding and subtracting part because we just want to multiply it. All right, so that gives us our rules. So for a new mean, if we're just adding or subtracting by a constant, then we take our old mean. So let's say our new mean is our old mean plus or minus whatever that constant is. Standard deviation, the new one, is the same as the old one. This is unchanged. This one we just add or subtract to get the new mean. Right. If we are multiplying, and remember multiplying is really the same thing as dividing, like the same thing if we just multiply by a fraction, that'd be dividing. So our new mean here would be whatever that constant is times our old mean. So we multiply or divide to get the new mean. With the standard deviation, we're also going to do the same thing. So our new standard deviation is just whatever that constant is times or divided by the old standard deviation. So we multiply or divide to get the new standard deviation. All right, and we can put these rules together. So if we're adding and multiplying, then we add and multiply to get the new mean. We just do the multiplying to get the standard deviation, and we forget about the adding part. When could this be useful? All right, the most time that this comes up is unit conversions. So oftentimes scientists will work with one sort of unit and you'll want to switch to a different unit, and we just have a unit conversion formula which involves adding, subtracting, multiplying, and dividing to get you new units. All right, so let's take a look. So a set of experiments leads to a mean melting point of an unknown liquid at 25.32. So that's our mean. If we wanted to, we could also call this x bar. It would work too for a sample. Our standard deviation is, let's just go ahead and call it a sample, x bar. Our standard deviation S would be 1.47. And these are both in degrees Celsius. And we want to convert to Kelvin. All right, so Kelvin is 0 for Kelvin is absolute 0, so we have to add a whole lot. So 273.16 degrees to Celsius gives us Kelvin. So if we want our mean in Kelvin, so let's say our x bar in Kelvin will equal our x bar in Celsius, so let's call this Celsius and this Celsius with a little c, plus 273.16. So this new mean in Kelvin would be 25.32 plus 273.16. And that would give us our answer in Kelvin. So let's bring out our trusty friend here. Get this stuff out of the way here. We've got 25.32 plus 273.16. And that gives us our new mean of 289.48. 289 or 298? I think I've switched those. 298.48. Yeah, I can read. All right. Our standard deviation, though, will not change because we're only adding or subtracting. So our standard deviation for K, that's right, I'm using S. S sub K will be the same as S sub C. Will still be the 1.47, and now it will just be in Kelvin. And this would be in Kelvin. And for whatever reason, they don't like to do degrees Kelvin. They just put Ks. But I don't know. All right. Otherwise, we could convert to Fahrenheit. Fahrenheit involves multiplying by 9/5 and then adding 32. So the mean in Fahrenheit would equal 9/5 of the mean in Celsius, 25.32, plus the 32. And we just have to work that out. The standard deviation in Fahrenheit, we'd forget about the 32. We just do the 9/5. Would be 9/5 times the 1.47. All right, so we're only doing the multiplying and dividing. We're not doing the plus 32 when we're dealing with the standard deviation. And we would just type both of those into our calculator to get answers. I'm going to move on here. A researcher performed faulty measurements in inches to get x bar, the mean, equal to 43 inches and standard deviation to equal 3.5 inches, and accidentally measured an extra inch for each measurement. However, she now needs to correct the corrected data in centimeters. Find the corresponding mean and standard deviation if she knows centimeters is 2.54 times her inches minus that one correction factor there. Okay, so the mean, to get the new mean, we just plug in. So the mean, the x bar in centimeters, will equal 2.54 times the 43 minus 1. We're just typing that in our calculator. The standard deviation in centimeters will be the 2.54. That's a multiplying factor times 3.5, but we don't subtract the 1 because adding and subtracting does not affect the standard deviation. And we're just going to throw both of those in our calculator. We're going to get 42 times 2.54 and 2.54 times 3.5, which gives us answer choice B, 106.68 and 8.89. All right, there is one of the ways we can do this sort of thing. So if we have two different sets of data that are what we call independent, so one does not rely on the other, and they each have their own means and their own standard deviations, and we want to put them together, Well, with the means, it makes perfect sense. So if we want to find the new mean of the sum of this distribution, if we're adding the x and y variables together, like one distribution is we're calling x, the other one's y, we just add the two means together. If we want to find the difference, we want to subtract x minus y, we subtract the two means. Real simple with the means. Standard deviation, though, standard deviation's a weirdo. All right, it has to switch over to variance. Remember, standard deviation squared is variance? All right, so it switches over to variance. And if we want to find the new variance, we add together the old variances. I like to think of this as just doing the Pythagorean theorem. The new one squared is the old one squared plus the other old one squared. So if we want to solve, we just take the square root of both sides. It's just like finding the hypotenuse. And it doesn't matter if we're adding or subtracting. So if we're adding and subtracting, it works the same way for standard deviation. So both of them are going to be plus. Kind of strange, but it still works that way. And it doesn't even have to be just two distributions. We could have like another one. We could have standard deviation of z squared and plus the standard deviation of w squared. Like we could have as many distributions if we want, and we want to combine them. We just add all the squares of those standard deviations and take the square root in the end. And x and y don't even have to be different distributions. They could be the same distribution. They could both be x. We could just be doubling it, x plus x. And that would work too. All right, so an example. Assume all are normally distributed. So we got to have, don't necessarily have to have normal to do this, but normal works because then our new distribution will also be normal. If we combine two normal distributions, we get a new normal distribution. The mean mass of an aluminum can without the soda is 15.5 grams with a standard deviation of 0.83 grams. The mean mass of a full can with soda is 358 grams with a standard deviation of 2.75 grams. What are the mean and standard deviation of just the soda? All right, so to get just the soda, we'll have to subtract the two. All right, so our new distribution would be the soda and can, so it would be the total minus the can. We can call it total and can, would give us soda. All right, so there's our equation. I don't want to use variables, I'm just going to use words. It's statistics, not algebra. All right, so for mean, so the mean for the soda would equal to the mean total minus the mean for the can. All right, so the mean for the soda is equal to, mean total was 358 grams, and they are the same unit, so it's okay, minus the mean of the can, the 15.5 grams. We're just throwing that in our calculator. Let's see, that'd be 43, so 42.5 grams. And there's our new mean. All right, so that's mean. To get standard deviation, we're doing the Pythagorean theorem. So the standard deviation of the soda will equal to the square root of the standard deviation for, we're just adding the squares. So it'd be 0.83 squared plus 2.75 squared. All right, and we would just throw that into our calculator. Where's our friend? There he is. It's been too long. He's gone to sleep. Second square root. We've got 0.83 squared plus 2.75 squared. We're all under the square root still. We press enter, and there it is. The standard deviation for our soda is 2.87 and some change. So this is 2.87, and this is also in grams. All right, now that we have this new mean and the new standard deviation, and we still know that it's still normal because they were both normal from before, what is the probability that the mass of the soda is less than 340 grams? Well, we know it's normal. All right, remember, this is still the normal section that we're working on. Mean is 342.5, so 340 would be somewhere down here. And we want to know the probability that it's less than that. So we got down this area over here, and this is 340. So remember, we've got a normal distribution with 342.5 and a standard deviation of 2.87. If we want to find an area and we have an x value, then we're using normal CDF. So remember, to find area or to find probability is normal CDF. We need a lower bound an upper bound, a mean, and a standard deviation. We've got all these. The lower bound, we're just going to pick some number way down here. 0, negative 1,000, whatever. Our upper bound is going to be this 340 where we want to stop. The mean we already said was 342.5. The standard deviation we already said was 2.87. And we're throwing that into our handy dandy calculating machine, the calculator. So second distribution, normal CDF. We've got negative 1,000. We've got 340. Sorry, yeah, 340. 342.5. All this calculator work is making this video longer than it should be. And 2.87. And we just press enter a couple times, and we get 0.19. All right, so this is 0.19, and that's our answer. Kind of lost my point there. So the probability of the mass being less than 340, about 19%. All right, last one here. Pete and Aaron both own separate tour companies in Las Vegas. Pete's company earns an amount of money each day with a standard deviation, so we're just doing standard deviation here for Pete, is 163.46. And now we're at Aaron's company. Her standard deviation is 165.03. What is the standard deviation and the difference of how much they make? So now we want the standard deviation of, let's see, Pete minus Aaron. So that squared is going to equal the standard deviation of Pete squared plus the standard deviation of Aaron squared. So to solve, we're just going to take the square root. So we get the standard deviation of Pete minus Aaron is the square root of 163.46 squared plus 165.03 squared. And we're just typing that into our calculator. It's definitely going to be something bigger. So these two are out of the game here. It's got to be one of the bigger ones because when we square things and add them, they get bigger. All right, which one is it going to be? It's going to be that one. So it is 232.28. All right, so sorry if that one was long. We went over transformations for mean and standard deviation. We learned what we're supposed to do if we convert. So we basically do everything to the mean. We only do multiplying and dividing to the standard deviation. And we're combining distributions. Again, we just do the normal things to the mean. Whatever's going on, that's what we do to the mean. Standard deviation, though, we use the Pythagorean theorem. And that is it for this section. So test coming up soon. Check out the Sporkle quiz. Get your homework done.